Okay, so we're going to do the first part here, which is implicit, which is what we started last time. So we're going to find dy dx and determine where it is actually defined. Okay, there are a lot of points on here. By the way, you cannot get y by itself, so we have to do it implicitly. Okay, so if I'm going to take the derivative of this, I get 3x squared plus 3y squared dy dx, or if you want to do y prime, that's fine, is equal to 1 times y plus x times dy dx. Okay, I'm going to collect all my dy dx terms on the left and bring all my non-dy dx dy dx terms to the right. Okay, so I'm going to bring this over and factor out the dy dx at the same time. So I get dy dx times 3y squared minus x is equal to y minus 3x squared. Okay, so dy dx is equal to y minus 3x squared over 3y squared minus x. Okay, I also want to point out that this is the same thing as 3x squared minus y all over x minus 3y squared. Those are exactly the same. Okay? All right, so that is dy dx. Both forms are acceptable. It's just flipping the signs, ESIGNs, and then moving terms. All right, where is it defined? Well, this is defined for every value as far as the numerator is concerned, but it's undefined whenever 3y squared minus x equals 0, or whenever x is equal to 3y squared. Okay, so as long as this relationship is happens, that x cannot be equal to 3y squared, okay, it holds true. So what are some points that it's not defined in? Okay, when y is 0, so it's not defined at 0, 0. When you plug in a y value of 1, your output is 3. Okay, so if I plug in negative 1, it's also not defined at 3. Okay, it's also not defined when x is 2. I scored 12 when negative, or at 12 negative 2, or at 12 2. So those are just a few sample points. But as long as it is not defined whenever this is true. Okay. 2 says, what are the tangent normal lines to the curve? I want to point out, by the way, this is just one point. When x is negative 1, y could also be negative 4. Okay? You know, another point that's on this curve is 1, 4, and 1, negative 4. But the only one we are going to find the normal and the tangent lines to is that point. Okay. So we need to differentiate this implicitly. Okay? You get 2x y squared plus x squared times 2y y prime equals 0. Okay? So we did it implicitly. Now we're going to get the y prime by itself. So I really get 2x squared y prime equals negative 2x y squared. So y prime, or dy dx, is equal to negative 2x y squared over 2x squared y. Thank you, Bell. All right, which really simple, but by the way, x and y cannot equal 0. I want to point that out. It's not defined there. It actually, that point is not on the curve if you really think about it. But x or y cannot be 0, which really is not defined there either. So what does that become? Y prime really equals the opposite of y over x. So what does that mean? The slope at any point is equal to the opposite of the y coordinate over the x coordinate. So in this case, what is that equal to is negative 4 over negative 1. So the slope at that point is 4. The normal line will have a slope equal to negative 1/4. Okay, so let's write the equation of those at that point. The tangent will therefore be y minus 4 is equal to 4 times the quantity x plus 1 The normal will be y minus 4 is equal to negative 1/4 times x plus 1. Okay? All right, the last thing on this page was having to do with inverse trig functions and differentiation, but a couple things we need to make sure we understand. What does this mean? Well, that is the same thing as saying y is equal to the arc sine of x. And remember, x is an angle. Okay, what does this give us? Okay, or I'm sorry, this finds an angle, x is a ratio. So this finds an angle given a ratio of x over 1, which is the opposite side over the hypotenuse. Okay? What does this mean? Or, well, first of all, what does the sign mean? The sign means find a ratio of, or it finds the ratio, this finds the angle, this finds a ratio of the opposite over the hypotenuse for an angle x. Okay, what does this do? Well, that's the same thing as a cosecant. What does that do? Is it finds a ratio of the hypotenuse over the opposite for an angle x. So this is finds an angle given a ratio. This finds a ratio given an angle. Okay, just so you understand what the difference is. Okay, thank you.